Hello, everybody. Hello, hello, hello. I know I'm late. I know I'm late. So, um, just kind of been all over the place, lately in terms of, usually like I have a bunch of ideas all at one time with like no way of completing them slash doing them. Um, we got a pretty good game plan setup of learning and doing things. I know that we got the software engineering courses that we're doing. We got a Unity training that we're doing to bring like really cool features and stuff to y'all later. So obviously that's gonna be a fun ride. Some blending stuff in the future as well. We got a lot of a journey to mark down together. But yeah, I am here. So if we noticed down in the middle there, that is a live stream going on during my live stream. I have a script that is getting worked on. And that script will be so that way every some odd seconds, it will flip to another friend that is live. So like Dorkshire is not live right now, so I can't put him down there, because he would have been my go-to. Didn't see, like Ryan and them on. So we went to our good old guy, Mr. Rook, Virtual Rook. So he'll be playing down there until the stream is over, and then we might find somebody else to put down there. If we got somebody talking in the chat at the time, we'll see if they have a recommendation to put down there. But other than that, we have our Unity stuff that we're learning. Got our Unity Essentials thing that we're finishing.
Welcome to Unity Essentials, your first step in learning to create interactive experiences within Unity. My name is James, and I'll be your guide throughout this pathway. If you've never used Unity before, or if you know a little bit about Unity but want more of a comprehensive introduction, you're in the right place. Learning Unity unlocks new creative possibilities and career opportunities. With Unity, you have the power to create amazing interactive games, worlds, and simulations across industries and styles, and then publish those experiences on different platforms. In this pathway, you'll gain a foundation in key areas of Unity development. First up is the Editor Essentials. You'll get comfortable moving around the Unity interface and learning how to navigate 3D space with ease. Next is 3D Essentials. You'll dive into 3D creation, designing a room environment with a bouncing ball physics simulation. Then, in Audio Essentials, you'll bring a kitchen scene to life with a variety of immersive sounds. To learn the programming essentials,
I don't know basic what's going on with my Vroid right now.
Collect objects.
I don't know if my camera's out of focus or what.
After that, there's 2D essentials. You'll discover the unique aspects of 2D game development by creating a top-down version of a familiar scene.
Oh, okay.
Finally, in the essentials of publishing, you'll learn to package your work as a shareable portfolio project, building it for different platforms.
Oh yeah!
By the end of this pathway, you'll have a strong understanding of Unity's core features, preparing you to develop more advanced and specialized skills. You'll also have a collection of fun, engaging environments customized with your own personal touch.
Well, thank you.
So, if you're ready, let's get started on your creative journey by learning the Unity Essentials.
I'm ready! I'm ready right now. Make a bouncy ball. Make a ball bounce off a ramp towards the corner of the room. this tutorial, you create a ball that bounces off a ramp and toward the corner of the rim. Eventually, you'll build a block tower that the ball will crash into, but first you need to get that ball rolling. Ha ha! As you complete these steps, you'll learn how to create new 3D shapes, apply custom materials, and implement physics in your scene. When you're ready to get started, go to the next step. Okay? Create and rename a sphere. Well, you know, it is quite start from the beginning here. So we need to go to kids' room. Kids' room scene. Hello? uh. Um. I think there might be something wrong with the kids' room. There's a living room. Kids' room is blank. Ugh. Alright, well, I guess it doesn't matter. It would have been pretty cool, but alright. So it's telling me to right click, create a 3D object that is a sphere. Okay. When you create the sphere, it may appear in a seemingly random location, which is actually based on the object you last framed in the scene view. You might not even see the sphere after creating it. Don't worry about its location for now. Right-click on the new sphere game object in the hierarchy window and select rename and rename it ball. Right-click. Rename the ball. Okay. Mark is complete. The ball is currently way too big. You need to make it smaller. Scale determines the size of an object, and Unity scale is relative to real-world measurements, where 1 unit typically equals 1 meter. Adjusting the scale of the ball to 0.25 in all dimensions makes it about the size of a standard kid's ball, about 1/4 of a meter in diameter, which is just less than 1 foot wide. Make sure the ball game object is selected, and then in the inspector window in the transform component, set the ball 0.25 across the whole scale. Alright, so in our scale, 0.25. Okay. You can also select the chain link icon next to scale properties to enable or disable constrained proportions. When this is enabled, changing one scale property automatically changes the other two by the same amount. Position the ball in the air. Now you're going to position the ball high above the floor near the window so that it can fall to the ground and bounce towards the center. Bounce toward the corner. Rather than using the transform tools in the scene view to drag the ball around, you'll enter the ball's precise position directly in the inspector window in the transform component. Every single game object in the scene has a transform component, which controls its position, rotation, and scale. Position values are measured in meters along each of the 3 axes, X, Y, and Z, relative to the origin of the scene. With the ball game object still selected, locate the transform component in the inspector window that is transform position X2, Y3, Z minus 1. Alright. Position X2, Y 3, Z, -1. Okay. Now you can tell which direction is positive for each axis by looking at the scene view gizmo. The colored cones point towards the positive direction for each axis. Create and apply a new material. The sphere primitive you added for the ball has a default material that is a very dull gray color. If it's kid's ball, it should be more exciting. Define the visual appearance of objects in Unity here. You'll create a new material in your project's assets and apply it to the sphere. In the project window, navigate to Unity Essentials and then Materials. Okay. Right-click inside the Materials folder and create a folder and name it My Materials. Create folder My Materials. Okay. This is where you'll keep your customs. Inside the new My Materials, right-click Create Material. Right-click, create material. Then rename the new material ball mat. Ball material for sure. Ball mat. Yeah, I've just created a new asset in the project window, which means that this material can be used in any scene in your entire project. You've added a new custom asset. Alright. Just create a new asset, which means that this material can be used in any scene in your entire project. You've added a new custom asset. You can see from the Create menu when you right-clicked that you can make all kinds of assets, including scripts, animations, fonts, and more. Drag the new ball mat material directly onto the ball game object in the scene view, which should make it turn the default plain white material color. It sure did. Remember to save your scene often. Adjust the material properties. With your custom material now applied to the ball, you're ready to adjust the material's properties to your liking. You can customize the ball color and how it interacts with light in the scene. Creating materials can get very complicated, so you'll start by adjusting 3 key properties. Base map color, the basic color of the object, a metallic map, how metallic the object looks, and smoothness, how smooth the object looks. Make sure the ball map material is selected in the project window. Okay. In the inspector window, in the surface input section for the base map property, select the white color swatch and use the color window to choose a new color. Red. Observe how your changes affect the ball's appearance. Adjust sliders for the metallic map and smoothness properties to your liking. Right, hold up. Yo, we can make it super metallic. That looks dope. Mark is complete. Add a rigid body and test. Now that your ball looks ready for action, it's time to bring it to life by simulating physics. To give the ball physical properties, you'll add a rigid body component to it. Without a rigid body component, the ball will stay at its current location in midair. But with a rigid body component, it will have mass and respond to gravity. Select the play to enter play mode and watch as your ball floats in midair. Select the stop button to exit play mode. Select the ball game object in the hierarchy window or scene view. Select the add component button at the bottom of the inspector window and then enter rigid body in the search bar. Alright. Ball. Add component. Rigid body. And select the rigid body component to add it to your ball. Enter play mode again and watch as your ball now responds to gravity and falls to the ground. Yep, it sure did. I am proud of that ball. It sure fell to the ground. Mark step is complete. Create and apply a physics material. Your bouncy ball's bounce is probably pretty disappointing. It behaves more like a bag of sand than a lively bouncy ball. To make it bounce, you'll create and apply a physics material. Unlike standard materials, which could... Oh my goodness, hold on. Alright, sorry. Good. Let's get back at the task at hand. Right-click inside the My Materials folder, select Create a New Physics Material, and rename the new material Ball Physics. Okay. So in My Materials, right-click, Create a Physics Material, Ball Physics. Okay. In the inspector window, set the bounciness property of this physics material to 1 for maximum bounce. Okay. 1. Alright. Drag and drop the physics material onto the ball in the scene view. Bonk. You won't be able to tell from the scene view that you successfully applied the new physics material until you test it. To observe the changes, press the play button. Hell yeah. Hells yeah. We made a bounce ball. We gotta show the Dorkshire. We made a bounce ball. Alright. And boom. Alright. Mark step is complete. Review the components. You have customized this ball a lot at this point. In this step, let's take a moment to review all the components that contribute to the ball's behavior and appearance in Unity. Select the ball game object in the hierarchy window, then examine the inspector window. Locate the transform component, so its position, rotation, and scale of the ball. This is the only component that is required for every game object. Locate the mesh filter. Determines the shape of your game object. A mesh is a wireframe 3D model. In this case of the ball, the mesh is set to a sphere shape. Locate the mesh renderer component. The mesh renderer component controls the external appearance of the ball. Try to find the material you applied to the ball. When you apply a material, it shows up in this component. Locate the sphere collider. The sphere collider component defines the physical boundaries of game objects for collision purposes. Try to find the physics material you created and applied. Locate the rigid body component. Rigid body component integrates the ball into Unity's physics system, giving it properties like mass and drag. Add a ramp and test collision. In this step, you'll add a ramp that the ball can bounce off. The ramp has to be positioned precisely beneath the ball, which can be tricky if you're viewing the scene from an angle. You'll see how to use the framing to help with this. In the project window, navigate to prefabs and shapes. Okay. In the Unity window, sorry, what? In the project window, navigate to prefabs, shapes. Prefabs, shapes, okay? Drag the ramp prefab into your scene and place it on the floor approximately beneath the ball. Okay. For precise positioning, select the ball, press F to frame it, then switch to the top view. Oh, true. Ball. Top view. Wonk. Not quite. All right. It went through the ramp. It went through the ramp. Notice the unexpected result where the ball passed through the ramp. Okay. Try to guess why the ball did what it did. Is there a type of component that could fix this? Yes, the ramp doesn't have a rigid body or a collider. Add a collider to the ramp. You will now fix the ramp by adding a collider component, which is essential for physical interactions in Unity. A collider is a component that defines the shape of an object for the purpose of physical collisions and interactions within the environment. Without a collider, an object has no physical boundaries and other objects can go right through it, like a cloud. The sphere primitive you added earlier in the ball already came with a sphere collider. That's what the physics material is attached to. Unity provides various collider shapes, such as sphere, cube, and capsule colliders. However, since this ramp has an irregular shape, you'll use something called a mesh collider, which conforms to the unique shape of the object's mesh. Select the ramp in the inspector, add component, add mesh collider. Okay. Select ramp, add component, mesh collider is now active. But I just did all of that on accident while in play. Alright, mesh collider. So now it should work. Bonk. Hey. 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 Okay. Okay, hold up. there was more to this. In the inspector window, add the mesh collider. In the mesh collider component, enable the convex property. Okay. Ramp, mesh collider, convex. In the mesh collider component, enable the convex property. Enabling the convex properties simplifies the collider into a convex shape, almost as if you were wrapping the object in some hard material. Unity needs mesh colliders to be set as convex to allow them to interact with other objects. With the mesh collider added and set as convex, enter play mode. I mean, did it change? I mean, it still bounced. Seemed like an extra step. Review and proceed. We are done with that tutorial. I think next we're tower. Yeah, I was going to say audio, but in this tutorial, you'll create a few block towers that your bouncing ball will be able to knock over. When you're ready to get started, go to the next step. Add a block and reset its transform. You're about to begin the construction of your block tower. To make your first building block, you'll start by adding a primitive cube. Just like you did with the sphere, you'll add it to the scene, rename it, then reset its position to the origin as a starting point. However, this time you'll need to use a new technique for creating the new 3D object and a new technique for resetting the object's position. Okay, at the top of the hierarchy window, select the Add button to access the Create menu, then select 3D Object Cube. Add 3D Object Cube. This technique gets you to the same menu as right-clicking. Rename the cube Block. Block. In the inspector window, select the hamburger icon in the upper right corner of the transform component, and then select reset to reset the transform. Alright, hold up. The hamburger icon. I don't see no hamburger icon up there. Select the more menu. Oh, is that what this is? And then select reset. Okay. Including resetting its position to the origin of 0, 0, 0. This should position the cube in the center of the room, halfway sunk into the floor. In this step, you'll reposition the block so that it's in the path of the ball and edit its scale so that it looks more like a classic kid's building block. However, rather than editing the scale in the transform component directly like you did with the ball, you'll actually use the scale tool in the scene view. After you master the scale tool, you'll have mastered the 3 most important tools in the scene view: move, rotate, and scale. In the hierarchy window, select the block game object, use the move tool to reposition the cube above the floor where it will get hit by the ball. Okay, hold up. Alright. What was it? Alt, left click. And then, yeah. I mean, we could have positioned ourselves so much better. Move. Scale. Rotate. I'm guessing this is shrink, yeah. Alright. I think I have that lined up where it'll get hit, but I think I already know the result. It's going to go right through it. Well, doesn't help that our camera is not in view of it. Camera. Alts. Oh, where's scaling? We're not moving. Bonk. Yeah, we did good there. Add rigid body. In the next step, you'll add rigid body component to the block object. So block, add rigid body. Okay. Initially, the block won't move when hit by the ball, acting like an immovable brick wall. This behavior is due to the lack of rigid body component, which governs the physics property of the game object. With the rigid body component, the block can react to a collision and fall over. Okay, so we didn't need to make any adjustments. And boop! I see the intention was there. Let's move that a little bit closer. The intention was there. The intention was to knock over. Did it knock over? Nope. We just don't seem to have that that oomph that we need, you know? Rotate. Was it? I can scale the whole thing. Need a little bit more oomph. Hell yeah! We got it. We got it, boys. We are currently blowing up Yorkshire's messages with clips now. You created a monster. Create a block prefab. In this step, you'll transform the block game object, which you've already enhanced with a rigid body component, into a reusable prefab. Prefabs in Unity are game objects with all their components and properties already set up that you can reuse as a template. You can use these custom prefabs in a folder in the project window for future reuse. In the project window, navigate inside the prefabs folder. Poor Dorkshire is having to turn his Discord off. Get away from my notifications. Prefabs folder. Select the add button at the top of the project window, then select folder and name my prefabs folder. My prefabs. Go into there. Click and drag your block game object from the hierarchy window into the my prefabs. When you drag a game object from the hierarchy window into any folder in the project window, it converts the object into a prefab. Observe that block in the hierarchy window turns blue, indicating it is a copy, or an instance of a prefab. It is blue. Create a tower from prefab blocks. Now you'll use the block prefab you created to build a small tower in your Unity scene. The process of constructing a tower not only tests your ability to use prefabs efficiently, but it also allows you to experiment with object positioning in Unity. The tower doesn't need to be perfect. As long as it stands up, it'll work well. In fact, it may even be more visually interesting if it's not perfectly aligned. From the Scene View toolbars, locate the center pivot dropdown and make sure that the center is selected. If the center pivot and global/local buttons aren't visible in your editor by default, click the 3 vertical dots at the top right. Good. Drag multiple instances of the block prefab from the project window into your scene, positioning them to form a tower. In order to make sure your blocks are aligned, you should examine the tower from all angles. Bro, you don't know the power in which you just gave me. Oh. Do I? Right. Block. Up. Scale out a little bit. Hells yeah. Hells yeah. Nope. Wasn't the button I meant to hit. Come on. Peace out. Oh. I forgot that it resets everything. Okay. Put a little like pie tower. We tried. We tried. Come on, get some speed in there. Ugh. We're not gonna stop until we get it. It was a start. We didn't even get the top one that time. Okay, we're gonna stop before we even knock it over. It's too strong! Target step is complete. Reduce the weight in the prefab. Oh, you might have noticed that the ball had a hard time knocking over all those blocks. By default, the rigid body component sets an object's mass to 1 kilogram. Your 1 kilogram ball is trying to knock over a tower made of 3 1 kilogram blocks. In this step, you'll reduce the weight of your block prefab. Okay. Block. Rigid body. mass, angular, constraints for freeze, layer overrides. So I'm guessing we mean mass. Hell yeah. We can do better. We can do better. Yeah. We did it. It's not all of them, but yeah. Alright. We'll try one more time for all. Alright. Go for it. 0.1 enough to get all three? Not quite. It was almost. It did move. It did nudge. Add a material to the prefab. In this step, you'll change the block's material using the prefab editing mode, so it's not that boring gray anymore. Open the block prefab in the prefab editing mode by double-clicking it in the project window. Okay. Then I'm guessing we're probably gonna add component material. Isolates prefab for editing in the inspector window. In the mesh renderer component, locate the material property of the block prefab. This? No. This. Element 0. In the mesh renderer component, locate the material property. Select the object picker next to the material property. This option opens a window displaying all available materials in your entire project. Browse through the list of materials. See various options, including some designed for furniture, floors, and so on, so some of them might have some unintuitive names. Select a material that appeals to you and apply it to the block. Okay. That's kind of a cool... Oh, look at that. Look at that. That's pretty cool looking. Is a prefab editing menu by selecting the back arrow at the top of the hierarchy screen. Oh, it changed those two, but it didn't change this one. Observe how the new material is now applied to all instances of block. All but one. Organize the blocks with the parent. In this step, you'll address the clutter in your Unity's project hierarchy window caused by numerous blocks prefabs. You'll learn to organize these blocks under a single parent game object, simplifying your scene and making it more manageable. As a reminder, a parent game object is a game object that serves as a container for other game objects known as childs. Children. These terms describe a hierarchical relationship, much like a family tree. In the hierarchy window, select the first block, game object, then hold down Shift key and select the last block, prefab. So. Create empty parent. Oh. Block. Blocks. Oh, block tower, but that's fine. This action creates a new parent game object with the individual blocks indented as child game objects. Rename this new game object something descriptive like block tower. Turn the block tower into a prefab. The block tower you've created consists of multiple individual blocks arranged in a specific structure. If you convert this entire structure into a prefab, you enable the possibility of reusing this complex object multiple times within your project. You'll see that prefabs are particularly beneficial when creating repeated structures or patterns in your game environment. In the hierarchy window, select the block tower, click and drag it into my prefabs. This action converts it into a prefab. Oh, wait. How did we get here? How did we get there? Blocks. 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 Okay. Add a few more of these towers to your scene to make it for a far more interesting collision, and then press play. I don't really think my placement of blocks is really going to do a whole lot there, but... Oh, yeah! I didn't think so. I didn't think so. It was worth a shot. Adjust the ball's mass. With so many towers in your scene, the ball may once again have a hard time knocking over all the blocks over. But what would happen if the ball was 10 times heavier? Or 100 times? Bro! What about 1,000? Ball. Rigid body. 1,000. Okay, like I thought it would like completely decimate the blocks, but it was definitely something. Review and proceed to the next tutorial. Mark step as complete. And complete the tutorial. Adjust lights, background, and camera angle. We did already adjust camera angle once. Because everything wasn't in camera view at first. Adjust your camera. Line the camera with the perfect view. Oh, we need to do this in a whole nother scene. Okay, alright, I'm coming. Unity Essentials. Scenes. Living room. Yeah. Oh, I guess we could put main camera. Okay. Field of view does not need to be that massive. Trying to get that perfect view. Oh, there's a preview I could be using. Definitely make things a lot easier, that's for sure. Okay. Alright, in the scene view, use fly through mode to get the perfect view of the bouncing ball and your block towers. Not even in the same area, bro. Select the camera game object on the hierarchy window. Control Shift S to align the camera game object with your current view. No way. What? That is such a cool thing to have. Oh, I duplicated stuff again. That is so cool. I love that. With the camera still selected, you could also go to the main menu and select Game Object Align with View. Enter Play Mode to test the new camera angle. I like that. I like that. That was pretty neat. Adjust your lighting. Lighting sets the mood and atmosphere of your scene. Unity's default directional light, which acts like the sun in the real world, simulates bright midday sunlight. By rotating this light, you can simulate different times of day or specific lighting conditions. In the hierarchy window, select the directional light game object, then frame it in the scene view. Rotate the light to adjust the shadows and overall lighting. Okay. So, our directional light here. Click it. Then it said we can rotate it. Change the lighting. Yep, we sure can. I'm more of a night guy. We're a cloudy day. Rotate the light to adjust shadows and overall lighting. Notes: changes in position won't affect the lighting due to its sunlight nature. It represents a light that's located infinitely far away and emits light in only one direction. In the inspector window in the emission section, experiment with color and intensity to find a desired lighting effect for your scene. Bro, what? Let's go. We're about to go to a blood moon real quick. Hell yeah. Hell yeah. Pretty cool. Oh, I mean to mark it as incomplete. Edit the skybox. A skybox in Unity is a type of virtual backdrop that surrounds the entire scene, giving the illusion of a distant environment of sky around the environment you create. Skybox contributes a lot to the overall feel of your scene. In the project window, navigate Unity Essentials Materials Skyboxes. Unity Essentials. Sorry. Unity Essentials. Materials Skyboxes. Okay. Click and drag any skybox that interests you. Hell yeah. That is awesome. I love that skybox. As you've heard a few times up to this point, when you're in play mode, none of the changes you make are saved. Make sure to pay attention when entering and exit play mode so that you don't lose your changes. By default, the editor windows around the game view become a tiny bit darker when you enter play mode to help visually distinguish between play mode and edit mode. This is known as the play mode tint. In this step, you'll edit the play mode tint to make it more noticeable so that you'll realize when you're in play mode and avoid losing unsaved changes. In the main menu, select Edit, Preferences, select Colors. Edit. Alright. Okay, we were Edit, Preferences, Colors. Edit, Preferences, Colors. Preferences. Oh, it said hold on. Colors. Okay. And then change the play mode tint color to have a subtle color instead of gray. Subtle. Play mode tint. Okay. Yep, that's pretty subtle. Very subtle. I don't know what y'all think, but I think it's pretty subtle. Next step is complete. Congrats on setting up lighting. Big perfect block tower, vertex snapping, add different shaped prefabs, add and frame custom artwork. Vertex snapping. Oh, we talked about that. Hold down the V button. Different shaped prefab blocks. Add and frame custom artwork. Session 2 quiz. What is a prefab? Nope. Nope. Yep. You add a primitive 3D shape to your Unity scene. What happens? Select 2 answers. Which of the following best describes the process for creating a new blue material in Unity? Which of the following are true about Unity's built-in components? Happens when you move and rotate the direction of light in a scene. Calculating score. Sweet. Audio essentials. All right, everyone. Well, I made it to where I wanted to be for the day. We got a whole nother chapter done. Next up will be the audio essentials section. Well, we will be looking into audio. I guess like putting audio and stuff. So that join yourselves. I know today was short. Done. So